Hey guys, hope you're doing well. Today we're going to talk about interior angles of polygons. And so some parts of the rule that we're about to talk about apply only to regular polygons. So I just want to quickly refresh kind of what we talked about in the last video about regular versus irregular polygons. So regular polygons are where all the interior angles have equal measure and all the side lengths are congruent. So this is all your squares, because if it's a square, all the side lengths have to be congruent and all the angles will be 90, and also equilateral triangles. So where every side is 60 degrees. And then now irregular shapes are when the interior angles may be different or the sides may have different lengths. So any rectangle is considered irregular. I know this one can be confusing because they all have the same angle, but they do have different side lengths, so they are considered irregular. And so the irregular is like most of the shapes you use. Regular is kind of just the basic square, the equilateral triangle, and obviously other shapes that have the same measure for all angles and sides. So now let's get into what we want to talk about, the interior angle rule. So for all polygons, not just regular, the sum of interior angles is 180 times n minus 2, where n is the number of sides. So 180 times n minus 2, that gives you the sum of all interior angles. And just so you know what I'm talking about when I say interior angles, that's just the angles inside of a shape. So if I have, let's make this a weird shape here, just it's the sum of this angle, this angle, this angle, this angle. All of those added up, that is 180 times n minus 2. So for regular polygons, so this is an important kind of rule, for regular polygons, each angle has to be equal to 180 n minus 2 divided by n. And let's kind of break down what we're saying. So we just said 180 n minus 2 is the sum of interior angles equals sum of interior angles. And think about what a regular polygon is. A regular polygon means all the angle measurements are the same. So what I'm doing is to find the angle measurement of any one side, I'm taking the sum and dividing by the number of sides, where n is the number of sides. And that's what the angle has to be, because all the sides have to have the same angle measurement. So this formula is not really one you need to memorize, you just kind of need to think it through. This is the one you've got to memorize. Sum of interior angles equals 180 times n minus 2. And we already knew the sum of the angles in a triangle had to add up to 180. So, and that's kind of where we start this whole formula. And so now you can find the angles of any shape. The rule actually comes from being able to add another triangle to any figure when you add another side. So let me show you what I mean by that. So let's start with a right triangle here. So we know that this triangle has 180 degrees, right? Well, if I make it a square, I'm adding another right triangle, aren't I? Let me make this bigger so you guys can really see what I'm saying. So I've got my right triangle here, and we know, because that's what we've learned, that this is 180 degrees. The whole triangle has a total of 180 degrees. Well, this formula 180 n minus 2 says that with every side I'm going to add, assuming it's greater than 3, I'm going to add 180 degrees. And that's because you can actually add another triangle with every side you add. So I'm going to draw another triangle here, and I know that this one's also 180 degrees, and now I have a square, don't I? One. So this is a right angle, this is a right angle, that's a right angle. So now I know that this whole thing, I took a triangle, I added another triangle, now I have a four-sided shape, and this says, well, the sum of the angles is going to be 180 times n minus 2 is 4 minus 2, which equals 180 times 2, which is 360 degrees. So with every side that I add, I'm adding a triangle which adds 180 degrees. That's where it comes from. If that's a little confusing, don't worry about it. It's not that important. It's more important to just have this formula down. So now let's get into some examples and see how we apply these rules. So what is the sum of the interior angles of an octagon? Well, I know my formula for sum of interior angles is 180 times n minus 2. An octagon, if you remember, is an 8-sided shape, so it's 180 times 8 minus 2, and that will be 180 times 6. And let me get my calculator out for this one. 180 times 6 is going to give us 1,080 degrees. So that is the sum of the interior angles of any octagon, no matter what. Okay, so now what must the measure of every angle be in a regular hexagon? So remember, if a hexagon is regular, that means all the sides are the same and all the angles are the same. So if I figure out the total number of angles, sum of the interior angles in a hexagon, I can then divide by the number of sides to find what every angle has to be. So Let's think about sum of interior angles of a hexagon. Again, 180 times n minus 2 is going to become 180 times 6 minus 2. 6 minus 2, which is 180 times 4. And that should be 720. So 720 degrees total. But now I want to know, what must the measure of every angle be in the hexagon? So while the hexagon is a 6-sided shape, I know the total has to be 720 degrees. I'm dividing by 6 sides, and that will come out to 120 degrees. So every angle in a hexagon is going to be 120 degrees. And let me just draw you what this is going to look like. A regular hexagon looks like this. So 1, 2, 3, 4, 5, and 6. That's really bad. Let me redraw that a little better. Sorry, I'm not an artist. That's why I'm doing math here. 1, 2, 3, 4, 5, and 6. So it's going to look something like that. You get the point. But what I'm trying to show is that 120 degrees is indeed what it will be. You can tell that it's an obtuse angle. It's nothing too big, but that it's what we're finding is that every angle here is 120 degrees all the way around the shape. That's what it means when we're finding the angle measurement of a regular hexagon. So hopefully that clears it up a little bit. All right, so now this last one, I had to draw this in, so pardon the poor drawing. So now it says solve for x. And this one might be challenging. I recommend you pause the video, try to figure out how to take this on yourself, and then kind of compare with what I got. So if I need to solve for x, I know that this angle here is congruent to this one. That's what this dash implies there. So I know that this is also 2x plus 10. 2x plus 10 degrees. All of these will be in degrees. And I know these actually are 90 degrees because they're right angles. So what I have to do is I need to figure out, well, what does the sum of all the angles need to be? And then I can just do an algebra equation. So the sum of the angles is a 5-sided shape. So 180 times n minus 2. N now is 5, so 180 times 5 minus 2 is 180 times 3. And that should be 540 degrees. So that's the sum of all of these measurements. So now I'm going to just do that algebra problem. So 540 equals 90 times 2, because there's two 90-degree sides, plus 2 times 2x plus 10. Two sides have 2x plus 10 degrees, plus x minus 5, because that's our last side. And now I solve for x. So 90 times 2 is 180, plus 4x plus 20, plus x minus 5. Combine like terms and bring the 180 over. So I'm going to get 540 minus 180 becomes 360 equals 4x. Oh, actually, I'll make it 5x. 5x plus 15. Now I'm going to subtract 15. I get 345 equals 5x. Do the division. 345 divided by 5. And what should that be? It will be 69. So x equals 69 degrees. And I'll write that up top here. So that's a big application of this sum of interior angles rule, but it's definitely something you guys can do. This is a really cool rule. This helps you with a lot of questions. It'll help you on the SAT. It'll help you in geometry. And it's just a good thing to know. So 180 times n minus 2 is the sum of interior angles of any shape. And for regular polygons, you can take that sum and divide by the number of sides to give you the angle measurement for every side. So hopefully this makes sense. Let me know if you have any questions, and thanks for watching.